such a material handling sync helps in generating higher output. And when it is shared, then this equipment is in a lot of conflicts. One of the conflict is whether I should be doing the logistical support activity or I should be doing the core activity. So what you will see in such environments is that at the assembly, some of the components have already reached, whereas some components have got delayed. So the assembly station will start starving. It's an issue of capacity wastage of the material handling equipment.
Hello and welcome to the Counterpoint podcast. I'm Shubham Agarwal and today we're going to be discussing about material handling equipment. Now, material handling equipment have always been looked upon as the logistical support for core operations in a manufacturing plant. While one may perceive their importance as not so significant, it is hard to imagine an environment where it can function efficiently without the presence of material handling equipment. In today's podcast, we'll understand how it hampers the output and the quality of a plant. We have with us Achal Saran Pandey, partner at the Vector Consulting Group, who's going to help us demystify the entire story. So let's welcome him and talk to him more about this. Hi Achal, welcome to the Counterpoint podcast once again. How are you?
I'm fine, Shubham, and thank you for providing the opportunity to express my ideas and views on this topic.
Great. So I want to start by understanding a little more in depth what is the key role that a material handling equipment plays in a manufacturing plant, especially the heavy metal engineering plants.
Okay, so let me try to explain with the help of an analogy.
Sure.
Let's take the example of a relay race. So you would have seen that in a relay race, the first athlete runs with a baton in his hand, and he hands over the baton to the other athlete, who in turn does the same, and this process goes on in the entire race. Now the team that runs in sync, where these all the athletes run in sync, eventually they are the winners. So
can you elaborate a little more? What do you mean by in sync?
Yes. So in sync means precise timing, that is no delays, as well as perfect rhythm, that is no interruptions. So when there are no delays and there are no interruptions, the team that runs in sync wins the race. Similarly, in the shop floor, the material handling equipments also carry their baton, and this baton is the material that they are carrying.
Right.
And they are taking it across various workstations. So when these material handling equipment operate in sync, that is without delays and interruptions, it provides operationally synchronous environment that helps in transferring the right material at the right time, at the right workstation, in right quantity and right quality.
Too much right.
So everything is right about it.
Everything is right about it.
Eventually, such a material handling sync helps in generating higher output, efficiencies, and a better quality output as well.
So Achal, I think the analogy really helps to understand how the material handling equipment is functioning, because you understand a relay race very intuitively, and so to understand the function of MHE is very easy. So thanks for that. Now, just to make sure that I understand it correctly, let us reverse the question a little and ask, if let's say the MHE or the material handling equipment were not there in the system, would it significantly hamper the operations, the output, the quality of the system?
So let's try to understand this phenomena with the help of two very important parameters.
Sure.
The first is the equipment utilization, which I'm talking from the point of view of constraint or bottleneck utilization, right? The other is the quality of output in the plant. So imagine a situation where the bottleneck or the constraint output or utilization drops. The entire plant output drops.
Because that is what it is dependent on.
Because it's dependent on. And on the other side, if the quality of output drops, then the effective capacity of the plant also goes down.
Rework.
Yeah, because rework is happening.
Right.
And so the effective capacity or effective output goes down.
Right.
So it's a situation of, it's a double whammy, in the sense that you have a lower output as well as you are incurring the cost of poor quality. Let us try to understand this phenomena in detail with the help of an example of melting shops.
Sure.
Now, in a melting shop, imagine a situation, and probably you'll have to visualize now, right? That there is a furnace and there is a molding line,
Okay.
right? And there is a ladle which is hung from a crane, and this ladle is carrying hot metal. So this hot metal is carried by the crane from the furnace to the molding line.
Okay.
Now, a situation can happen where this ladle has reached the molding line much before its scheduled arrival. So it will have to wait.
Yeah.
If it waits, the hot metal starts cooling down.
Cooling down, right.
So it will have quality implications. The other situation could be that this ladle comes late to this molding line, later than the scheduled arrival. So this molding line will be losing capacity.
So it arrives late.
So there is a classic conflict. On one side, it's the utilization of the molding line. The other side is the quality. And so this operation has to be run in a very tight sync to ensure that both the needs or both the parameters are achieved.
Right. No, so I really understand the importance, because the explanation really, with that example, the two cases where it is delayed or it is coming early, clearly illustrates how it is hampering, and especially in a steel melting or a casting operation, if I were to call it, right? Material handling equipment are available throughout any plant or any manufacturing facility for that matter. But is it that, just to broaden our scope of understanding, there are industries where it hampers this significantly as well?
It is evident everywhere, but it is significantly evident, you can say, in these in industries such as steel plate manufacturing, in beam manufacturing, in fabrication shops, big fabrication shops. It is evident in all these areas.
Right.
And why it is evident in these particular industries is because in these industries, the metal handling equipment is not only playing the role of a logistical support, right? But it is also playing the role of providing, or it is also involved in the core operations.
Oh, okay.
That is being conducted in the shop floor.
Oh, so it is no more just the handling equipment.
Yes.
It is also the core operation.
Core
Can
operations.
You detail it out a little for us?
So for example, I'll take now the example of a metal fabrication shop.
Sure.
Now, in metal fabrication shop, you have various individual work centers. So for example, drilling, machining, and many work centers like that. And then you have an assembly operation. So what happens is specific operations are conducted in each of the feeder workstations like drilling and machining, right? And then the components are assembled at the assembly station. All the logistical activities like loading, unloading, and transfer is normally done by the crane, and these are typically 10 to 15 ton crane.
Right.
As well as in assembly, they play a major role in core operations. So what happens in assembly, since it is a very heavy load, these plates are very heavy, you have to turn the plates or you have to rotate the plates so that you can weld various components. So they play a very major role in
the core operation.
In the core operations as well. So they are playing both the roles over here. Now the issue is that these cranes, these metal handling equipment or crane are shared across all operations.
Obviously. Right.
In most of the environments. And when it is shared, then this equipment is in a lot of conflicts. So one of the conflict is whether I should be doing the logistical support activity, or I should be at any moment in time, or I should be doing the core activity. That's the first conflict. Right. Which one to do first? The second conflict is that within the logistical activity, should I address the drilling work center? Should I address the machining work center? Or some other work center?
Right.
So it's
do you see that happening a lot in actual environments where you have probably been there? And
yes, it happens a lot. And when it happens a lot of ad hoc priorities goes on, and which eventually leads to a lot of losses in the system.
So if there's an environment which is struggling with such conflicts, how do these conflicts generate losses? If you could explain that a little more in detail.
If this is a shared resource across multiple activities, eventually the entire operations goes into a desync. And remember, we talked about when it's sync, so you get very good efficiencies and all. We have just talked about everything is right. But now everything is not right in this case.
Clearly.
So what you will see in such environments is that at the assembly, some of the components have already reached, whereas some components have got delayed.
Oh, okay.
So the assembly station will start starving. What happens is that in such an environment where the material handling equipment such as cranes are shared, then they tend to lose sync. That is one of the symptoms that you will see over there. The second thing that you will see is that individual feeder workstations like drilling, machining, they go into an underutilization mode because of this conflict and the loss of sync.
Okay.
Right? Also, what happens is, since the assembly workstation is starving and the crane is not available, then the operators or the supervisors, they try to turn these heavy components or metal plates with inadequate tools and equipments, such as they will use long bar as levers, long iron bar, metal bar as levers, clamps. So they were using some ad hoc ways to do that.
Right.
That actually creates dents, damages.
And that's a hazard for safety as well, I guess.
It's a hazard for safety also and quality also. So these dents and damages will in quality, and then the safety aspect is obvious, because if it falls or then it's a dangerous situation.
Yeah. But the cranes are not such a big investment. I understand it is a big capex to start with, but if you look at the entire scheme of things, it's not such a big investment. So why not just increase the capacity? Why not add some material handling equipments and take care of that? The priority conflicts, or the conflict that where should I take the equipment first? Is that not going to solve the problem?
Shubham, this is not an issue of low capacity of material handling equipments. It's an issue of capacity wastage of the material handling equipment, right? So the capacity is already available with you, but it is not being used properly. It is being mismanaged, right? This mismanagement comes essentially from two areas. The first area is the way the planning and production is happening on the shop floor. And the second is the way the priorities of these equipments are being managed on the shop floor.
Oh, so you're saying that there is something about the prevailing practices in terms of planning or production that hampers the capacity. We have excess capacity, obviously. Can you elaborate how the current practices that generally are followed in plants across the country or across the world, for that matter, hamper this?
Okay. So the first point that I would like to highlight is from the planning perspective. There is a capacity wastage happening because the way the material is being planned on the or released onto the shop floor. Assume that I release the material much more than the actual consumption or the actual requirement of the customer. So a lot of material will get accumulated onto the shop floor, right? Your WIP will bloat up. Now, eventually what will happen, a high WIP will occupy a lot of space, and these are heavy metal plates or heavy metal components. These are not small ones. So very soon you will find there's a lot of space constraint happening on the shop floor. And to manage that space, right, you will need these equipments or a crane, say for example a crane, to arrange and rearrange the material onto the shop floor, to retrieve material which is hidden below somewhere in the entire heap of inventory, to retrieve it. So a lot of capacity
additional
of the crane,
steps will have to be taken.
Additional steps have been, and these are all capacity wastage for the crane or the material handling equipment, which is not envisaged earlier, because this is an operational issue.
Never there in the planning.
It was never in the capex also planning, because this is an operational issue, right? It's not a capex related issue, right? The second point is talking from the capacity wastage from the perspective of production.
Okay.
Right. And when I talk about production, I'm talking about a lot of capacity of these equipments are used to manage a lot of breakdowns happening on the shop floor. Some conveyors are misaligned, some rework has to happen. So all these issues are coming up which have not been addressed, and so the crane is being used to do this rework. The third issue is in terms of the efficiency of the MHE utilization. Now, when I say efficiency, that I have suppose a 10-ton or a 15-ton crane with me, but I'm using it to lift most of the lighter loads like 1 ton, 2 ton loads, right?
That's
So,
also a wastage of capacity.
it's actually diverting the capacity to lift tonnages and they're occupied with those activities when the higher tonnage component have to be lifted. Since they are focused in lifting lower tonnages, then the delay happens in lifting the higher tonnages because the capacity has got diverted to these areas.
But the planned equipment for that lower loads is already involved in another operation, and that's why we have to use this. Or what is the condition where we have to use?
What happens is in many of these manufacturing environments, they are using the same crane. So 10 ton to 15 ton crane, if they are using, I'm just taking an example, right? They are using it for lighter loads also, and they are using for heavier loads also.
Okay.
Right. So when they are using for lighter loads, again that's a prioritization issue that I'm using it for lighter loads.
Yeah.
The heavier load lifting is delayed. So imagine a scenario that if I had some mechanism where I could manage the lighter load with through that mechanism, the crane capacity could be diverted directly to lifting the higher loads for which it was made.
Yeah. Right.
And so then I'm efficiently utilizing the equipment.
So I get an understanding that there are ways in which the capacity is being lost somehow or the other way. Like you said, in planning or production, the capacity is being lost. Now, I'm sure companies or plants do understand that they are losing capacity, and they would make some amendments or some corrections in the way they do work that they recover the lost capacity. So what are those practices? If you can understand that as well, it will be really helpful.
See, once these manufacturing plants lose capacity, right? They have some catching up to do. Normally what they do is they do it in two ways. The first is they will start lifting higher loads than the prescribed limits so that they can catch up. The second thing that they tend to run these equipments at higher speeds also. So when you run these equipments with higher loads and higher speeds, you are actually creating a wear and tear in the equipment. A lot of wear tear happens. Right. In case of cranes, it can also, higher loads can lead to misalignment of cranes, right? Which damages its wheels also and the tracks, if you observe. So this generates a vicious loop. Now the vicious loop happens is because the wear and tear has increased. So these metal handling equipment will go under breakdown. It will create further desync or loss of sync. And again, you will try to run at higher speeds and higher loads. More efficiency loss, more output loss, and more quality issues. This is not only from the point of view of efficiency, output, or quality. It's also very dangerous. It's not safe.
Could be some accidents.
There could be some accidents also occurring at the same time.
Right.
So that is the idea.
Right, and whenever such a situation happens, when there is such desync or such mayhem, that's where the vector enters. So I want to ask you, how do we start solving it? What is the direction in which we should think if we were to solve these desync issues, these delays or interruptions or lost capacity as well? How do we start on that journey?
So we should look at two aspects. The first is efficient planning and production, and the other is there should be a mechanism that sets up the priorities for this metal hanging equipment, as well as manages their capacities efficiently.
Okay.
The first is an efficient planning and production system. So we typically have two kinds of environment. The first is what we call as the MTS or made to stock environment. So in a made to stock environment, in many of these organizations, the material is released onto the shop floor much more than the actual consumption by the customer. When that happens, the WIP starts bloating up. We had discussed earlier as well. When the WIP starts bloating up, a lot of
additional operations or
a lot of arranging, rearranging, retrieval of material. These MEHs are involved in those kind of operations, and the capacity loss happens. The other environment is what we call as the MTO or made to order environments. Now, in this case, the metal is released continuously onto the shop floor to prevent the bottleneck from starvation. So there are a lot of orders that are released onto the shop floor. So that there are so many orders onto the shop floor that the bottleneck does not starve, or the constraint does not starve.
There's always work available.
There's always work available for it. So even in these environments, with so many orders coming onto the shop floor, the WIP bloats up, and again the same issue of managing, rearranging, arranging of material, on the shop floor as a retrieval happens. So the issue comes in both kinds of environments. Now the solution is that in case of MTS environment, there has to be a mechanism, a release mechanism, which ensures that only that much material is released onto the shop floor which is required by the customer or consumed by the customer, not more than that. So when that happens, you will eventually have a control over the WIP on the shop floor, so you will not have any space issues, and so you will not deploy these metal hanging equipments to arrange or rearrange the material. And you will get enough flexibility to respond to customer demand as well. In case of MTO environments, the release mechanism should be based on the customer due dates, and that's the only criteria for releasing the metal onto the shop floor or orders onto the shop floor.
Right.
And while doing this, we should ensure that there's enough material available before the constraint so that it does not starve. So there has to be a mechanism which takes care of both. And so in case of MTO environment, if we are able to do both the things, then we don't have any WIP issue and no arranging or rearranging material. So it works very well. So basically what we require is a release mechanism for both MTS environment and for the M2 environment.
Got it. And what about the prioritization and the capacity management?
So in the capacity management, normally in such shop floors, if you see there are shared, these metal handling equipment are shared amongst various workstations, even departments also, right? So there are ad hoc priorities floating around, right? Particular MHE has to go to a particular equipment is based on some ad hoc priority, which may be some urgencies coming at that point of time. Now, what we have to do is that we need to have a mechanism that gives these triggers or signals to the MHE to go to the right workstation to conduct the right activity. Number two, we'll have to adopt what we call as a time boxing method. So if there are certain activities which have to be done and which is not related to its core operations, which this MHE's operation, there are some additional activities which have come.
Sure.
This can be done in certain time zones that you can think of, like for example lunch, right, where the plant is not operating, and we can do those activities during that time, right? So it does not interfere with your regular activities on the shop floor when the plant is running, right? A third mechanism could be to release their capacity, is that on the shop floor you see these cranes are handling these bigger cranes are handling smaller tonnages also, or should I say the bigger MHE equipment like cranes, they're handling higher loads also and smaller loads also. For smaller loads, these cranes may not be required. You can say they are over-designed somewhat for handling those smaller loads.
Right.
So might as well handle those smaller loads with mechanisms such as jib cranes, the smaller cranes, and release the capacity of the bigger cranes to perform the activity related to higher loads. So such kind of planning, production, as well as priority management and capacity management of MHEs can give a lot of good results, and we can do much better on operational parameters and such as utilization, output and quality.
Right, that's really wonderful. I think Achal, I'm sure all our viewers, people who have this problem in their environments, would really relate to it and understand in depth why this is happening and how they can correct it. And people probably who have not experienced it so up close would understand how much such a small thing also, which we perceive as a small thing, can mean for the entire environment. So thank you once again for enlightening us on this topic, and I'm sure that the viewers are going to love us. For all the viewers, like always, this was something on material handling equipment and how we can improve the output of a system by correctly planning and correctly prioritizing the work that we had at hand. We'll keep coming back with such interesting episodes. This is Shubham signing off. Thank you.